So, hey everybody, and welcome to another episode of In Conversation With. If you are joining us on Friday night over on the Azure Live Twitch.tv channel, then thanks so much for tuning in. Please do take part in the chat below. And don't forget to give the channel a follow. That way you'll get notified when we go live next time. Equally, if you're over on YouTube and you're watching this on the catch-up, then thanks very much for watching. Please do hit that like and subscribe button. It really is appreciated. Okay, so my guest this week, he gets to view the world from 30,000 feet up as an airline pilot. And that's just one of his day jobs. He's also a .NET developer working closely with Xamarin and IoT. If that wasn't enough, he's a Microsoft MVP and still finds the time to put so much great knowledge back into the community as a host on things like IoT Live and other brilliant things across the Microsoft space at the moment. So on that note, it gives me huge pleasure to welcome my next guest on In Conversation With as Mr Clifford Agius. Hello, Cliff. How are you doing?
Hey, Johnny. How are you?
Yeah, very well. Managed to get through that little introduction without too many retakes, eh?
Yeah, it's only a second attempt.
You just got to sit in the background and chuckle away and laugh at me when I try that anyway. But anyway, how are you keeping? All good?
I'm good. I'm in my den. I'm in my workshop at the moment, so which is nice.
Oh, I did notice that. Yeah, very nice. So not flying today then. So got time to have a catch up with me.
I'm flying again on Thursday to Dallas. So yeah, a couple of days off Dallas, a couple of days off Dallas again, a couple of days off, and LA at the end of the month. So getting around. Yeah, most of the US at the moment.
It sounds very glamorous, Cliff, but I guess it's a job. It gets to a point where it's a job. But yeah, I think lots of people be nice to fly over to America and hop off the plane every now and again.
Yeah, it's great to go certainly to the US at the moment because they are open. Or most states, a couple of states are still closed, but it's as if COVID doesn't exist. You go to Dallas, Texas at the moment, you don't need to wear a mask if you've had your injections.
Right.
And nobody's wearing a mask, and you chat to staff in the restaurants, and they say, "Well, how do we know whether they've been injected or not? So how do we enforce it?" So it's like a rule that's been put in place, and there's no way of enforcing it. So yeah,
well, I think
no masks.
I think that's the story of the last 18 months or so, I think, isn't it, Cliff? Where, but hey-ho, hopefully, fingers crossed, we're getting out the other side and we don't have too many hiccups on the way out. But, I mean, firstly, Cliff, thanks so much for joining me. Obviously, we've been in contact with each other over the last X number of months. I think I'm an avid watcher of your show with Pete over on the IoT Live show, which I think, is dangerous because every time I watch a show, I end up going on to Pimoroni or one of the other sites and spending about a copious amount of money on stuff.
I've got boxes of bits up there that we talk about, and Pete mentions, and I go and buy it, and I mention, he goes and buys it. So we've pretty much got the same boxes of bits that I must play with that, and you just don't get time.
No, I'm exactly the same. So, I mean, before we dig in, I mean, there's so much that we can go off and talk about. I'm sure we will now over the next 45 minutes, an hour or so. I mean, we'll see how far we get with this one because I think there's so many cool areas. But, I mean, firstly, Cliff, before we jump in, I don't know if you want to give yourself a quick introduction. Just obviously, I gave you a little bit of an intro there to begin with. But before we kick into the cool stuff and what we're talking about, if you just want to let everybody know who you are, what you're up to, and where you going?
Yeah, well, as Johnny said, my name's Clifford Agius. I'm an airline pilot, a senior first officer for a major UK airline. I fly the 787 aircraft. It's a plastic fantastic, so it's the latest from Boeing. I get to fly that around the world, mostly to the US. The last 18 months with COVID, it's been next to no passengers, but lots of cargo, which has been okay. It's keeping us afloat, but we need the passengers to come back, so we need you to buy airline tickets like you bought toilet roll. I should have worn that T-shirt. I've got that on the T-shirt. It's brilliant. When I'm not at 40,000 feet, doing 600 miles an hour, somewhere around the world, you'll find me sort of working on an IoT or Xamarin project. I mix kind of mobile and IoT projects for clients. It's not the only thing I do. I stay in the .NET kind of ecosystem and Azure for all the projects I work on for clients. But yeah, mainly IoT and Xamarin are my core kind of areas that I work on. And when I'm not doing that, I'm trying to, help the community learn and work with local schools to try and help them teach kids as well. And if I'm not doing that, I work on projects like this, which is handy to hands, to prosthetic hands. I built for a local friend's son So yeah, he has this as a full arm. So that's me. You'll find me on Twitter at Clifford Agius. I'm on GitHub and all the other places, LinkedIn and the likes, and you can find all those. I'm sure Johnny will share those in the show notes at some point.
Yeah, no, absolutely. I think we'll gather all the links together and it'll be in the blog post to accompany this video, Cliff. Yeah. But I mean, I think, where do we start, Cliff? Because I think there's so much to kind of dig into. And I think maybe we start at that sort of education part, because I think this is partly the reason why I love getting brilliant people like yourself on these shows, Cliff, because if nothing more, if I get one or two people viewing these episodes, it's like a free one-on-one session with somebody that's a bit more intelligent than me and can impart their knowledge into areas that, I think it's gleaning that knowledge out of people. And I notice one of the things that you're a massive advocate of, Cliff, is kind of pushing this education thing into the schools and into the school syllabus and things like that. I mean, I did have a chat with Pete a good few months ago, and there's some really cool things going on with the likes of, Raspberry Pi and other companies like that. They're doing stuff. What's your take on it at the moment, Cliff, in terms of education in schools and the whole programming and tech teachings? Where do you sit with all of that at the moment, Cliff?
Yeah, well, I mean, if I go back to when I was at school, I mean, the reason I love tech and love coding and love programming, and I'm sure, many people of the same kind of age, and everyone goes on about, you go to a tech conference, it's a middle-aged white guy that's there at a conference, or he's in the tech industry. But if you look back to where that all comes from, and I think Dylan Beattie is a big advocate of this as well, is the fact you look back at where it comes from when we was at school back in the 80s. BBC Micro, the A and the B, was what was in schools, and everyone got to play with it. But sadly, for whatever reason, the girls were never interested, so they went off and did what they did. But as guys, boys, we all jumped in and played with this new whizzy computer, and we learnt to code. Admittedly in BASIC at the time. And now it's a case of, well, the BBC master and lot has disappeared, and in schools, the government has sort of said schools must teach ICT skills. But I got three boys. Two of them are still in secondary school at the moment, and they come home and their ICT stuff was things like Word, Excel, and stuff like that, and they might look at a bit of Scratch programming, but even that was really, really basic. And they've been doing stuff with my boys at home, Scratch programming. We've done stuff with Unity. We've played with HTML code and JavaScript and CSS, that sort of stuff. Just trying to give them a feel of how the internet works. And silly things like that. We've played with lots of IoT stuff, like little I forgot what they're called now, the little meow bits and microbits, and that, and the boys love it, and that. So one of my sons took his little meow bit, which is like a little sort of self-enclosed little LCD screen. He programmed a little game on that, and he spent hours on it doing it. And he took it to school and showed his teacher. His teacher was like, "That's awesome, it's fantastic," but they're not given the skills. So these teachers are like dumped at the deep end with, like, you must teach ICT. And it seems to be whatever teacher puts their arm up is the one that goes and teaches it. But they're given next to no training. So I offered my skills to the local schools and said, look, I work in this industry. I'm happy to come along and help teach it. And we've been trying to teach and come up with lessons for the kids to try and teach them a bit of coding, because they're bored of Scratch. Scratch is, like, as everyone knows, it's a block-based programming language. And once you've done a few of them, it's it's like boring. What else? What's next? And if you go and do like Scott Hanselman, just after Build, recently put out the new .NET tutorials website, and I'll need to find you the link. But and it's fantastic. But it starts off with Hello World as a console app. So teenage kids, I mean, do they really want to see Hello World? No, it's boring. So they want to see something fun. So Pete Gallagher's course on the robot arm, which is I've actually got my one. It's falling to bits. I've got my one here.
I'll reach to get mine. Yeah, I saw your one. That's pretty cool. You redesigned that arm, didn't you? Yeah.
Yeah, well, my eldest son, Macaulay, took a design off of Thingiverse, which, if you don't know anything about 3D printers, there's a website called Thingiverse. And if you can think of it, it's probably on there. It's like a GitHub for 3D designs. He took the design from that, but it was a really long print, and there was some quite technical bits in the print, and you need to have like support material on that. So I basically gave it to him and said, look, and we, between the two of us, I used to be an engineer. I worked in the car industry for many years as a electrical mechanical engineer. So I kind of redesigned some parts of it, certainly around the base here and this central arm. And he went in, edited the files, and come up with this much simpler design and really, really quick, easy. There's no support material needed, and it prints on any 3D printer. So we're now looking to print a bunch of these and put them into my son's school, and then plugging them into a Raspberry Pi and getting the kids to code them. So now they're actually moving something. This is like getting them that kind of, that beginner part of getting into actually moving physical things and seeing code do something, rather than it just moving the scratchy cat around the screen or hello world on screens of text. So actually getting it to move stuff. So then it can program things. I remember when I was at school, we had this turtle thing that had a pen in it, and you'd program it, and it'd go forward 40 paces, turn right, and you could get it to draw like a simple thing on a big bit of paper, stuck to the floor. But this is, they can pick things up and do robotics and and that sort of stuff. So, and then we'll move on to doing other things, that maybe get a little car, 3D printed car for them, and get them to drive around the course and stuff like that.
Well, I was going to say, Cliff, I mean, it's cool to see that you're doing that with your kids' school, because I did a similar thing. I signed up to become a barefoot ambassador with BT and the British Computer Society. They do like they look for technical people just to volunteer, and you go into school and you help the teachers with their own personal development. Because I think half the time what you find, like you said, it's the first teacher to put their hand up that's got an interest or at least knows how to turn a computer on, so to speak. And it's no disservice to the teachers. Obviously they're there doing their job and they're not expected to be tech wizards. But I think one of the things I signed up for was to help not just instill like that computer science type vocabulary into everyday syllabus lessons, so kids are aware of the kinds of what tinkering is, and kind of what bug fixing is, and it's just tinkering around trying to fix. It's introducing those kind of concepts into everyday syllabus, but is to help the teachers as well get up their game effectively in the space. So I mean that's cool. I mean, again, we're going to go off and talk about all this in a little bit more detail, but I mean, the fact that you're stepping up, I think we need more people to do that, first and foremost. Don't you think, Cliff?
Everyone needs to step up and just, even if it's only like an hour a month that you can give to, supporting kids, because otherwise we're going to end up with nobody coming into the industry. And those that do come into the industry are, and it's in, a friend said recently that everyone's going into Python and PHP and the likes, because that's what they learn at school and college. So when they come out of the industry, they're coming out as Python and PHP developers, which is fine. And, a lot of companies are now going down that route, certainly, the Python route with developing projects, because they're getting cheaper people, which means they can pay them less. So, .NET developers, or whatever is your favorite language, if it's not Python, then, it's driving prices down. If you do want to get a job, and it is in, my friend who lives in the US is saying, the only jobs he can find at the moment are Python related. But the pay is way down here, not what he was used to as a .NET dev up there.
Well, and it's a higher abstracted language as well, isn't it, Cliff? At the end of the day, so I think one of the things that drew me to the stuff that you were doing, the stuff that Pete was doing, was that whole, actually let's get back down to basics, exactly like you've just demonstrated there. Let's actually make something. Let's put a motor. Let's put an LED on it. Let's do something and make something move. So I mean, for everybody that's watching, I mean that in itself is potentially, because I know, because you and Pete have already had me. Hope there's a fly coming to attack.
Yeah, there is. Yeah.
Oh, hang on. Is that not an IoT fly? Was that planned? Like
No, that was a TCAS event. It got too close. Yeah. So cataclysm avoidance system. So we didn't have planes get too close. Yeah.
But I mean, the barriers to entry, I mean, obviously we've spoken about, kids, obviously with teachers in schools at the moment, they need to kind of their own personal development. But I mean, if it comes to somebody that's looking to get into the absolutely brilliant world of IoT, I've got to add that, because I've had so much fun over the last, well, what's it been, Cliff? Probably at least 7, 8, 9 months, I guess, since I probably first started focusing a bit more on it. But what are the kind of barriers to entry that you see for individuals trying to break into IoT and do this kind of stuff?
Well, I'll go back to, and literally this was only last week this happens. The school can't even install VS Code on the machines in the school because, like all big schools in the UK, they hire in the IT equipment from a company, and the company lock the PCs down. Nothing can be installed other than Office 365, which is what runs the system. There's no other software unless the school go to them and say, "Pretty please, can we have this?" And they won't install VS Code. So if they've not got VS Code or Visual Studio, there's no need for kids to have Visual Studio, let's be honest. But VS Code should be, a simple thing to install, but they can't install it. So what's it called? GitHub
Code Spaces.
Code Spaces, that's it. Thank you.
Yeah.
GitHub Code Spaces is out there. So I messaged the team because they did another big announcement to build. I messaged the team last week and said, "Well, we've got Code Spaces, and we can run Code Spaces, which is effectively VS Code in the cloud against the Git repo." But the problem is, then all the kids and the teachers need their own GitHub accounts, which again is a problem because you've got to be above 13 because it's an American company and you can't have an account, yada yada yada. We all know that with YouTube and Google and everything else. So that negates the younger kids, years 7s and 8s, which is not ideal because you want to get them in straight away. So I've just basically said to the team, can we have it such that they can have like a school level, an organizational level, get Code Space account where the teacher is the one that's organized it, and they just give, student A, B, C, D or whatever. And they're like, that's a brilliant idea. Let's do it. So now, this all started last week and there's emails flying around everywhere.
But couldn't they use live share or something like that? If the teacher had one account, they could use live share over it with
but then the problem with that is then that means that the student can't go off and do their own thing.
Yeah. So they're doing it on one terminal.
Go home and do it as homework. They can't then just go, because we all know what it's like. You'll have 2 or 3 people in a class of 30 that will get really interested, and they'll go off and just hack and do whatever they want to do in their own time. And it's given them the opportunity to do that. And they could go and install VS Code in their PC at home, but maybe they don't have an iPad at home because so we don't want to stop the kids from learning because they don't have the tools. So the first thing is, let's put the tools in their hands. Once we got the tools, then we can come up with some stuff. I've spoken with Bill Wagner, who looks after the docs team at Microsoft, because they've got try.net. I know it's complicated to say, but it's try.net. And you go there, and again, it's much like the you got the REPL and everything else, so you can do the Hello World stuff and things and that. And I was saying to Bill, I was on a conversation with him as an MVP, and said, we need to get the younger kids in, because otherwise, in 5-10 years' time, there'll be no .NET developers because everyone's coming out of college as a Python developer and going straight into Python or web world. And you'll only
what is it, Cliff? What, in your opinion, what is it with .NET over something like Python? Is there some fundamental thing that is more beneficial, do you think, or?
No, I as a .NET developer, it's what I know and love. But I think it's also the fact that you can do more with it. I don't know why. My mind seems to think that, with Python, you kind of, you can do circuit Pythons, you can play with IoT stuff, you can do Python that will run a website and that sort of stuff. But then when you want to get into industry seems to need the .NET stuff because, they've got all these Microsoft tools and they want you to write a bit of code that creates a new app for Teams or that sort of thing. So it's where, if we don't have the students learning the fact that it's just a language, another language, pop across that barrier. Whereas at the moment they're being taught, because .NET does run on IoT. I've got a Feather board behind me, or you can the Meadow F7 board. Sorry, not Feather. The Feather's the Adafruit board, which you can run Circuit Python on, or you can use the Nano framework to run .NET on IoT as well. But it's looking at that, and also you then start getting into doing cloud stuff like with Azure, AWS, that sort of thing. You then kind of need that higher level language, not Python, which is not as a high level in my mind anyway. I know there's probably people screaming at their screens now, no, you can do it all.
Well, I think the way I see it, I don't disagree, but I think you're always going to have people that are used to using a certain programming language. And the way that I viewed it over the years, I mean, you look at things now like C. That C gets mentioned. I'm by the way, I'm no means a developer or a programmer. I keep saying to people, I know enough to be dangerous, but of course, over the years, you dip in and out as an IT pro, you go in and out, and so you get a general feeling for it. I did a little stint a while back of doing a bit of programming, and I think the way that I see the industry going at the moment is that the lower level programming languages and even sort of circuit programming and things like that. When you step it up to things like C and then C++ and object orientated and C# and then .NET, and you kind of go through the motion where we're at the minute with all of these languages that seem to be the craze of the day, I suppose is the best way to put it. Things like Python and Go and other things like that, is that they're quite a higher level abstracted language, so they get rid of all the complexity in the actual formatting of the syntax of the language. But fundamentally, if you know the concepts of programming, what variables are, what classes are, what methods and functions, and what these concepts are, you should be able to turn your hand to most languages. It's a case of learning the syntax and finding the relevant framework or library that may contain some of the things that you might want to do. I mean, that's my view on it. But I think to a layperson like me, somebody coming in to IoT trying to do a bit, so right, hang on a sec, I have to kind of blow away the cobwebs and try and program something, whether I choose Python or .NET, I need to try and do something. I mean, what are the barriers to entry are there when it comes to like the hardware, for example? You mentioned there, you've redeveloped a robot arm, which is fantastic, and they could almost be printed off and sent to schools in kits. But I mean, as an individual, actually, we mentioned 3D printing. But being able to go on to something like Thingiverse or a Git repo, pull down some code and pull down some 3D printing files to make something. I mean, how do you see that going at the minute, Cliff? Because they're, 3D printers, they're not as ubiquitous, they're not as out there as, not everybody's got one hidden under their desk. I think, this is a warning to everybody. If you start watching IoT Live, it won't be long before you do go and buy one. Yeah. But I mean, what's your thoughts to people, maybe the older generation looking to break into IoT? Is it necessary? What's your view on it? Do they need to rush out and buy a 3D printer? Do they not? What's your take on that kind of thing?
I think for IoT, you don't need a 3D printer at all. It's more, the ubiquitous hello world for IoT is Blinky, turning an LED on and off. That is the hello world of IoT, and we've all done it. You get your board, you plug in an LED, and off you go. But it's simple things like to teach IoT. And me and Peter talks about this, is putting together a package that will be relevant to schools, because it's not a case of just plug the LED in. Well, where do I plug it into? Which port should I use? Because there's lots of different GPIO pins on a board. Well, what does that even mean? General purpose input output.
Yeah.
What does that mean? To a child or an adult, it's confusing just off the bat. But then, okay, well, I plug an LED in, but it's not working. Well, you got it around the right way, because an LED is like diodes only work in one.
Well, it's electronics, I suppose. It's fundamental electronics at that stage, isn't it? Yeah.
Then you need to know the fact that, well, my LED went pop. Well, yeah, did you put a resistor in it in line with it to do the current limiting? It's little things like this which seem as barriers to entry, but it's just like opening up your VS Code, whatever is your idea of choice, and having a blank screen in front of you, and not knowing where to start, not knowing that you need to put system.io at the top, or whatever using statements you need to do, system.maui or Microsoft.maui even. But it's those different barriers. So me and Peter talked about putting together a package and a Git repo that literally takes you through those simple first stages of becoming an IoT dev, and just to get you to know some of the very basic bits. I mean, Pete's repo and learning tutorial on that robot is fantastic, and I highly recommend anyone to go and give it a try. Even if you don't have the robot, just going through the tutorial will teach you enough about IoT to do it. If you don't have a 3D printer, don't panic. There you go. You've got the bigger one. Yeah.
So I was going to say, I mean, I went through it and I highly recommend it. But unless you've got a lot of patience, don't go for the bigger robot, because it is there, because this is held together by a ton of steel.
Yeah,
There's lots of pins and screws.
This one is, you can just about see it, is the arm of the motor, or the servo, holds the next.
Right, yeah.
So we've made it as simple as possible. So all you need is the 3D parts, 4 of these little 9G servos, and that's it. You don't need any other screws, because the screws that come with the servos hold it all together. You need the 3D printed parts. If you don't
and the little servo 6 board as well, for the the servo.
Do at the moment, but we're going to see if we can get rid of that as well.
Okay, that's cool.
What was I going to say? If you don't have a 3D printer, you can go on to. I've got Prusa printers next to me here. If you don't have a printer, you can go on to prusa.org, and you can go on to their. They have a service on there where you can find somebody who's got Prusa printers near you, or another printer, but it's mainly Prusa printers on there. And they will. You can send them the files, or say, "Pretty please, can you print this?" And they'll print out. I've done loads of projects. I printed a project the other day for somebody who contacted me on there and said, it was an anime kind of figurine they wanted. I printed it out. It was an 11-hour print. I set it printing overnight, come out in the morning, it was all printed, good to go, stuck it in a box, posted them. And they paid for the cost of the filament and the postage. I don't add anything onto it. It's this person wanted it for an art project and they wanted it in white so they can paint it. Good luck to them. It's a college project they were doing for art, and it's like, there you go. Good luck to you. And it cost them a few pounds in postage and PLA plastic. It wasn't a lot at all. But a robot arm. When we did this, me and Pete did a tutorial session with a load of techs at Microsoft in Dublin. And we had quite a few of them come along, and we basically printed out all the 3D printed parts with the garage team and on my printers and sent them out to them. But I was managing to print all those components and post them to Dublin for literally less than £2. It wasn't a lot at all.
Yeah, it's amazing though, isn't it?
Envelope, 'cause it's all flat. So you can get the parts and make the start, or just go through the repo without the robot, and the servos will just move on your desk. It'll do the same job. It just won't be a robot. But you can do that as well.
Because I guess one of the things that I know Pete has shown me before now, things like using virtual Raspberry Pis. So it's all there in a browser. You don't necessarily have to go and of course, if you're doing the robot arm, you may need to go and buy a Raspberry Pi or some small computer, like you say, with GPIO. And these are all barriers to entry. Yeah, I mean, let's roll this back a little bit. So I know certainly for me, it's becoming a little bit more second nature now talking about these things, because it's taken me personally, that good 8-9 months to kind of work my way through, do the blink in the LED, write the Hello World programs and get there. And I think the one cool thing is it's really good fun. The process is what I found. I really enjoyed getting to the point that I'm at now. There's so much more you can do, even dipping into the electronics and, me casting my mind back to those GCSE electronics exams from yesteryear, thinking, like you say, which way round does a diode go, or which way round does an LED go, and things like that. And, these aren't, I wouldn't suggest they're simple things to pick up. They take a bit of focus and attention. I mean, so just to answer, Cliff, to kind of package all of this stuff up, why should somebody be interested in IoT, do you think? Why should they be interested if they're not already?
I think it's the future. Everything's being connected to the internet. And, me and Pete have talked about it on the IoT live show, which is on Tuesday nights at 9 p.m.
Yeah.
It's a shameless plug.
Tonight? Or not tonight?
No, it is on tonight. Well, not tonight.
I know, but not when this video goes out. Yeah, exactly.
What was I saying? Yes, everything's been connected to the internet. Now, when I learned as an engineer, when I worked in the car industry with Ford Motor Company for 11 years, I was taught electronics. I was taught, how to, wire things up, connect it, get a robot to move. And we're talking big commercial Cincinnati Kuka and Kamau robots to weld the cars together, all this sort of stuff. That was it, but there was no it was just there was no internet. It connected back to the factory servers, the mainframes up in the roof space and the offices. But now everything is connected to the internet. I mean, you buy a new washing machine and it wants to connect to the Wi-Fi. Why? But it does. So it can send you a message to say, "Oh, I've finished cleaning the clothes." Most washing machines go beep, beep, beep when they're finished. Then you walk past it, it's I'll empty that later, and you forget about it. Then you go back the next day, and it's like, "Oh, I forgot to empty yesterday's washing." We've all done it. But everything's connected to the internet, and you look at the studies that come out from the big the big kind of industry companies that look into all this sort of stuff, and they're saying that the growth space for tech in the next 10 to 15 years is going to be IoT, because all these big companies are looking at putting things out in the field that are all going to be connected back to the cloud. So you need engineers that know how to do that. So the biggest growth in the tech industry over the next 10 to 15 years is going to be IoT. It's going to be small little components out in the field somewhere. They're going to send a little bit of data back, maybe to an edge device, which then sends it back up to the cloud. And it's at any point in that kind of ecosystem, you can be involved. Maybe you're heavily into code and the clouds and Azure or AWS or whatever. Or maybe your low-level systems and embedded systems, which is where I tend to be happiest. So or maybe you're somewhere in the middle, like the network structure that's in the middle. But it needs kind of engineers to work in that field. So if you're just starting out or you're looking for your next kind of thing to move into, IoT's a good place to look and go. Because all the big companies are doing it. Everyone's turning to how can we make this, work on a device that's somewhere out in the middle of nowhere, powered by solar and sending its data by 4G or 5G back to the cloud. So even LoRaWAN, which is a radio frequency system that works for kilometers, we're talking many, many kilometers. Those sorts of things are where I think the industry is going to be moving in the next 10 to 15 years.
I couldn't agree more, Cliff, and I think it's certainly why I've decided to turn my interest to it, because as you guys know, it's one of those areas where it's not like any other IT niche, I guess. It's just the best way I can describe it, to learn IoT is just fun. I think, it sounds a bit silly, but it's not like, I look back for when I did, some courses around databases and sort of, I forget the tables that you call, but like the one-to-many, multiple, one-to-one, but, and you just sit there and you just fall asleep reading a book. It's like, it really isn't a smiley, happy. Well, I didn't find it. Apologies to all DBAs out there now that are throwing things at the screens. But what I'm trying to say is that as an area of IT and where IT is going, all of a sudden now, you just suggested there that making gluing some sensors together, putting things somewhere, powering off solar power or lithium batteries, all of these things require skills and disciplines that they are in short supply of. I think it's probably fair to say.
You look at the 787 fly around the world. It's got 2 Rolls-Royce engines, Trent 1000s on the wings. Those engines have got sensors upon sensors upon sensors detecting everything. You think your car has enough sensors on board. The engines are, they're expensive bits of kit, and really fine bits of engineering, but got loads and loads of sensors which feed back into the aircraft systems. Us, pilots can look at that data and the bits of data that they share with us as pilots, and the rest goes into the data recording system. We all heard of the black box, which is actually orange. Don't get that right. It's called a black box, but it's bright orange. It's all recorded there. But the new Rolls-Royce Trent 1000 engines, all that data is sent to the cloud. It's all sent from the aircraft live by satellite link.
I was going to ask you that. I was going to ask you that. Yeah,
we're flying through the clouds, but it literally goes to the cloud. So it's all sent to the ground. I've been on an aircraft when we first got the 787s at Heathrow. The very first flights was always met by Boeing and Rolls-Royce engineers, because it was an entry into service in the UK. So it was brand new aircraft, and it's always been met. But we're being met by the engineers, and they knew things about the aircraft and what happened on the flight. We knew nothing about as pilots, because it was a small sensor that had gone offline because something had happened, and it was a subsystem of a subsystem of a subsystem, And the aircraft had seen the problem and solved it. Fixed the problem, and nobody on board the aircraft knew, because it was it was one of the backup systems. And for anyone that's interested, the 787's got a left and a right rack. In each rack, there's 16 computers, so that's 32 in total. Each of those have got an A and a B channel. So the numbers start adding up, and any one of those can do any bit of the aircraft systems.
Wow. Okay.
So if one of them goes down, it's noticed by the others, and the others just say, "Oh, fair enough. I'll do that bit. You do that bit," and they share the workload. If it's it gets to being one of the serious major systems, then it tells us, the pilots, that actually that's just gone offline. And typically on the 787, the trick you got to learn, which wasn't something you do on other aircraft, is you sit in your hands and give it a minute or two, and you get loads of error messages and that, and then all suddenly disappears. The computers take over and look after the systems. But
certainly not switch it off and back on again at 30,000 feet.
Delete now and again, but only when we're on the ground, not in the air. Not in the air.
Yeah, absolutely.
But all that is IoT. All
Yeah.
that system is literally IoT, because all connected. Not just the Rolls-Royce engines, but the rest of the aircraft systems connect via a data system back to Heathrow and our engineering team. And I've been on the sat phone with our engineering team saying, look, we're seeing this problem, and we're okay to carry on, we're okay to continue the destination, but we think we're going to land and give your engineer a big headache of something to fix. Just thought you'd want to look it up and tell your engineer he's going to need this bit from stores, or go and look up the manual, so that when you land, and what we're thinking there is the commercial operation, because when you land, the aircraft's on the ground for as short as possible time before it gets flying back. So and we're talking to engineers, and they're like literally 2 minutes after we're talking to them about seeing an error code in one of the computers, they're saying, "Oh yeah, we can see it now," and "Yep, okay, right, we can see what that is. Yeah, that's a bit of an oddball. That is. We'll look at the manual for that. That's not seen that one before." And this was what was what is happening, and it's all IoT, and that's a commercial aircraft that costs $250-300 million to fly around the world. And then you look at things like all your self-driving cars. It's effectively IoT. Me and Pete quite often say that mobile phones is IoT. It's a it's a computer that connects to the cloud. It's essentially IoT, which is why I tend to sit in kind of Xamarin or Maui, as it now is, mobile development and IoT, because a mobile phone is full of sensors. You've got all your IMU sensors for your inertial navigation and that sort of stuff. So it's the IoT field is growing hugely, and everything will be connected to the internet in as I say, next 10 to 15 years. If your washing machine is today, you think of what your car is going to be doing when it's driving itself around the world or around the local streets. And it needs engineers to work in those spaces. I've got friends that still work at Ford, and they're working on the driverless car technology and the electronic vehicle technology, which we'll see on the streets in 5-10 years time. As the new Ford motor vehicle, but it needs engineers, and they're struggling to find engineers that have those skill sets.
And I guess for anybody watching, it seems like a massive jump from not being in the world. If you work in IT in any shape, position whatsoever, a step into IoT, I think, does open up these kind of Pandora's boxes of things that you've got to kind of dip into and learn and understand to a certain extent. But and there is a big jump from flashing an LED and having thousands of sensors on an aircraft engine at the end of the day. But it's all of those bits in between, I guess. It's just that creativity of, you've got a real world problem, and that you can detect things with certain types of sensor, but now the barrier to entry with actually, how do we gather that information from these sensors? How do we process that data, and how do we send that message to the cloud? And I guess this is where learning the cloud, and we talk a lot about Azure. I know on IoT Live, we Pete certainly has done some work towards the AZ220 exam, but the actual end-to-end piece there, all of a sudden, these barriers are starting to get knocked down quite quickly. Do you think that, Cliff? I mean, what's your view on the actual Azure side of things then, the cloud platform for IoT?
Yeah, I mean, it's changed over the last couple of years. I mean, I never used to use, the I bit of my IoT projects, never really used the cloud because the offering wasn't brilliant. it was either expensive or the barrier to entry was just far too high. Whereas now it's it's super easy, pretty much free. And, connect your devices and have a basic tier or the free tier on Azure IoT Hub or IoT Central, and it's almost pennies, if anything, to connect devices to. So you can practice, play, and learn. I highly recommend the AZ220 course. I know you've done it, Johnny. I'm yet to do it, just because everything gets in the way and I'm too busy. But you can go through the AZ220 course. Pete and Jürgen's Pluralsight course is absolutely amazing. I know you use those as well.
Sure did,
docs.microsoft.com as well for your docs on it all. But yeah, I mean, the place to start is get a couple of boards, and it's not expensive. You can pick up a Raspberry Pi Pico board for £4. And that's enough to get you started. A couple of LEDs. I mean, you could get going. I've got one here somewhere.
So I'm just grabbing my pack. I've yet to open pack of 3 there. Yeah, that's it.
Yeah. I never opened the original one that got my magazine because I wanted to keep it, so I've left mine sealed.
It'll
be a collector's item in a few years' time, I'm sure.
Yeah, no, absolutely. But yeah, they're only a few pounds each, aren't they? And it's just that entry. And I think you can program in .NET or Python on these.
You can program
.NET Core
in C, in Arduino C.
C is it?
And it's Arduino C, which is a version of C. There's a version of Circuit Python on there. I don't think they call it Circuit Python. I think there's another name for it. I think Circuit Python is the Adafruit name for theirs.
Right,
there's another name for it. I can't remember off the top of my head. And the Nano framework, which is .NET Land, they're basically porting it to the Pico at the moment.
I saw your talk the other day on that, actually. Yeah, that was pretty cool. Yeah.
So they've got the basics there, but they're bringing in things like generics and stuff like that at the moment. So that's coming as well, which means you'll be able to write .NET code to run on a £4 device. And that is where, when we start talking about going into schools, now the barrier to entry is super low. Because now the school could probably fund buying each student a board which they can take home and do the homework on. Even the Raspberry Pi. I mean, they keep the cost at £30, and the only reason you get new ones is because the component cost has gone down, such that they can upgrade. And the cost is always. You listen to Eben Upton, the founder of Raspberry Pi Foundation. He always keeps the cost the same, and we get a new version like version 3, version 4, version 5, because the component cost has gone down enough that they can then move on to making something with a faster processor and more components.
Sure.
And the reason component costs go down is because we've all got mobile phones. So the technology that's in the Raspberry Pi 4 now is mobile phone technology from 4 or 5 years ago. But now the Qualcomm chips that are there are not being used in mobile phones, but it's cheap and easy to make because so many mobile phones depended on them. So now the Raspberry Pi team can actually buy millions of these chips and put them into the Raspberry Pis that we know and love. So give it a few years again, and we'll have the latest and greatest chips that are in the latest smartphones now. And that will be on a board that costs you £30 that you can plug into a normal TV and plug in a normal keyboard. And, if you don't need a special monitor, you just need the board and that's it, you're off to go.
That kind of plays into what you were just saying then, Cliff, in terms of where are we going with tech in the next sort of 5 to 10 years and IoT, and just that cost, the Raspberry Pi, the fact that the price point of some of these boards and the power that you get with these boards is, over the next 5 years, like you say, in 5 years' time, if we end up with a Raspberry Pi that's got the capabilities of a standard average PC by today's standards, wow, they're going to pack a punch, at the end of the day, and just imagine what you can do with these things, I
mean, the Pi 4 that's out now has got the equivalent of a PC from 10 years ago. So, that's how fast the IoT world is moving. And, it's, like you said earlier, for me, when it's a database and doing, effectively forms over data, and you've got a website that collects data and puts it in a database, another bit of the server that takes database data and runs it all together and puts it out to a Power BI, thing. That doesn't float my boat. I find that, a little bit boring because it's just data being moved around. Whereas, to sense data in the real world and, work out what that's telling you, be it like a camera feed is going into cognitive services, that sort of thing. That's what floats my boat. Anyone that knows me knows that I've worked on Handy.
Yeah, I was going to say about Handy. Do you want to take us through that, Cliff? And before we go into Handy, I think we just need to apologise again to DBAs. We keep picking on databases here. As we got to pick. It's a proof of point.
It's fun.
I'm going to do the next video is going to be on databases and how fantastic they are. Yeah, take us through Handy, Cliff, because that was I got wind of this a while back now and saw that you've done this, so I thought that was pretty cool. So
So basically, Handy is a use of IoT. So and a real world use. A friend of ours, their son Caden, was born with no left forearm, so he's basically got a stump here from his elbow and the rest of his arm's missing. And to have a prosthetic limb made by a National Health Service, the NHS here in the UK, is super expensive, even for I've got one here actually. One of Caden's old arms. There you go. So that's what you got from the NHS, and it's got a hook at the end, and you got a strap here that goes across to his other shoulder. And as you move his shoulder backwards forwards, it pulls this. This is actual fishing line, 100-pound fishing line that sea fishermen use, and it pulls that and it opens and closes the claw. So as you move your shoulder backwards and forwards, it opens and closes the claw. That costs the NHS. The arm part here, which gets replaced every year, between 4,500 and 6,500. The hook at the end, between 1,500 and 2,500. So not much change out of £10,000. By the time you bake in the hospital's time, everything else, and the family going to the hospital, and all that sort of stuff, it's quite expensive. This is 3D printed on 3D printers, and the total cost of this with the arm, the battery, and all the sensors and all of it is 500.
Right.
Now, admittedly, it's got my time in there as an engineer to develop it and work on it. But now the design is pretty much there. It's on my GitHub, so you can go out there and download it and print it and do what you want. We can print these for £500 and build them for £500. So, and then there's a mobile app which allows you to set it all up and configure it, which means you don't need to go and see the technicians at the hospital to then adjust the setting because your muscles have gotten a bit stronger. Because obviously, when Caden started, his muscles that are here that we use for sensing were very weak because he's never used them. But as you use a muscle, it gets stronger. So then you have to dial in the settings because now the muscles are a lot stronger. So you can adjust all that with a mobile app. So that is a real world use of IoT for good. So, it's not just a case of blinking an LED and grabbing, people giggle at this, grabbing temperature and humidity sensor data and send it to the cloud. That drives me nuts because that is blink LED, get temperature and humidity data, and then you're good as an IoT program. That's what the world seems to think.
I plugged this in especially for you. Plus, I just wanted to see. Yeah, I'm at 30. Apparently, I'm at 34 degrees in here, so I don't know how true that is, but that I am warm.
Yeah.
So I plugged that in especially for you, Cliff.
The reason it drives me nuts is, and Peter tested this as well, is the fact that you start out as an IoT developer, and the first lesson is blinking LED. Second lesson is grab IoT data and send it to cloud. And it's always temperature and humidity, and it's like, right, you're an IoT dev. Good luck, see ya. And then the rest you're left on your own, and it's like, well, hold on, let's fill that gap. And that's what me and Pete are hoping to try and do, is take you from, how do you go from I know nothing to actually I can go and get a job in IoT. Now, going out as and doing the AZ220 course is brilliant. That teaches you the I. That teaches you how to connect things to the cloud and how the cloud works, and IoT Hub, and IoT Central, edge devices, things like this device, which is the Azure Percept. It's got a camera and a multi-array microphone for doing directional and stuff like this. This is fantastic bit of kit. It's certainly for the £350 it costs. It's awesome. But again, that is teaching the cloud side. So the AZ220 and I dare say AWS have got their own version of the same thing. That teaches the cloud stuff, but you need to know how to create devices to send that to the cloud. How do you get your Pico that you've gone and bought for £4 and a few sensors to take, how full a tank level is in a grain silo, for example. How much, I did a project with a company that was working in shipping, and they wanted to know what the ship was doing, and they basically wanted to catch the ship's captain out. The ship's captain would write in the captain's log, as we all know and love from Star Trek, star date, whatever it was, and they'd write down what was happening that day. And what they'd do is say, we anchored up because it was force 10 gals and the ship was everywhere and it was unsafe to travel. But really, they'd anchored up and going to get a bit drunk. So what the company wanted to do was put devices on board the ships that sent back daily whether the ship was A, moving, and B, what its pitch rate and roll angles and everything else were, so they could see. And then when the ship's captain, and they caught a few captains out before it got round that actually you can't lie anymore, they basically could see the fact that the captain had falsified the logs, which is I didn't know what the ultimate result of this was because I wasn't shared that information. I was told, can you send us data back via satellite link of what ship's doing? I was like, well, yeah, it's just a IMU sensor for doing the measuring of the various angles and magnetometer and that sort of stuff, and send it back via a U-Blocks satellite data. And when you send that data, you get the GPS coordinates of where the ship is at the time. So therefore, you know its speed and stuff over the course of the last 24 hours. So I did all that, and then they used it to obviously do what they did with it. But that is, not really using the cloud, the AZ220 bit. That is knowing the device structure and knowing how to build a bit of tech. And it's that bit you need to learn as an IoT dev. You can do the cloud stuff, but you need the people who know how to make the tech. And that is the end that I'm happiest in, rather than the cloud end. I know the clouds and I know how to use it and I know what I'm doing there. But I've gone from the electronics to the cloud, whereas a lot of people start at the cloud end and do that side and then try and learn the electronics. And it doesn't matter which way around you go, but you do need to have an appreciation of both.
I agree, I think there's probably more to it than just that as well. I know you try and bring things back down to simple forms, but I think just the sheer amount of things. I mean, the cloud platform in itself. When we talk about cloud, it's always puts a smile on my face, a wry grin when somebody says, "Oh yeah, I'm an expert in the cloud." It's like you're not. I can guarantee you're not. But it's just that I think it's when you branch into things like IoT and certainly, like you say, where things are going in the future. All of a sudden, we just feel overwhelmed. I guess to somebody that doesn't currently work in the industry or wants to work into the industry. I mean, have you got any kind of advice on the best? You said that you and Pete were looking at maybe starting up, some kind of training material. But have you got any sort of basic advice for somebody looking to break into the world?
Yeah, I help mentor a couple of people that are getting into IoT world and tech at the moment. One is actually from doing the stuff I suggested. Has now got a placement with the Royal Navy, working as an engineer, working in exactly this field because they're looking. Even the Navy, the Armed Forces, are looking to put IoT onto their ships. And onto their kit, so they can not only just track them, but work out what's going on with them and stuff like this, and send it all back to their version of the cloud. But started out with basically get yourself a basic Arduino board because that is kind of the ubiquitous kind of starting point. The Arduino, if you go onto their website, they've got a learning platform. They can go on there and learn the basics. And the reason I suggest the Arduino, because unlike docs.microsoft.com and the likes and the Pluralsight courses, they're all kind of leaning towards the clouds. They're all leaning towards the higher end stuff.
Sure.
Whereas Arduino, because they make the electronics, they're teaching you how to blink an LED, how to control a servo motor, how to connect to the Wi-Fi, so you can send that data to the cloud. Yeah. So I started her out as learning that. And she was at college doing engineering and electronics. And in her class, and she was the only female in a class of a load of guys, but they were basically being taught really basic kind of bits around electronics and software, but not to the degree that she would have needed to get the job with the Royal Navy. So she, family, friends and stuff, she contacted me and I was like, yeah, okay. Look at this. So she went and I think the Arduino course is got, I think you buy the book and it's 30 or 35 pound. I can't remember off the top of my head now.
Yeah. Okay.
And you need one of the Arduino, I think it's the Uno board, I think it is, and the kit. I think she spent in total about 65 pounds. And she had all this kit, and you go through the book, and it starts off blinking LED, and at the end of it, you're effectively building a robot. Little servos moving around, and sensors, and all sorts. Ultrasonic sensors and that, and you're building like this little robotic car. And if you got Lego, then you basically build a little car, and it all moves around and does stuff. And it's brilliant, and that teaches you enough basic electronics and basic kind of coding skills. Because, like you said earlier, Johnny, an if-else statement or a for loop or a do-while loop is the same. The syntax is slightly different, but it's the same in all programming languages. So once you know what an if-else is, whether it's C, C#, Ruby, Golang, Python, PHP, it doesn't matter. It's a if-else statement, So she's done that. She's gone on. She's now literally just gone down to Southampton to start her course in becoming an engineer for the Royal Navy.
Oh, that's pretty cool. Yeah, that's really cool. I mean, and I think that the journey never ends, though, Cliff. I think it's just a case of, I'm sure you'll attest that. I mean, certainly the stuff I see you and Pete talking about, it's it's just one of those things. I think you kind of, in my experience, it's you've got to kind of have a little bit of a passion there to want to learn and want to do these things, because they certainly take a bit of focus and persistence and patience.
Yep.
In my experience, that you're not going to get things right straight away. It's going to take that tenacious kind of attitude where you just keep going back till you get things right. But no, that's some cool tips.
But the thing is, as we was chatting about this, it would have been NDC London beginning of last year. It's NDC, Norwegian Developer Conferences all over the world. But it's mainly focused on kind of .NET lands. But I went along, engaged and talk about Handy and IoT there. And we were talking after hours at the pub conf, which is the conference which moves to the pub. And there's a few of us talking, and we half of us were MVPs, the other half were not MVPs, but were really well known in the industry, but they worked in different areas, so they weren't Microsoft stack. There were other stacks like Google and things like this. So the MVPs or whatever they're called in their various stacks. We were talking about it, and we come to the conclusion, and actually I'm yet to disprove this, but you look at any people that are active in the community, like yourself, Johnny, like Pete, like me, all the people that are active in the community and are doing a lot and teaching a lot and helping the community and that, well, all the people that actually never stop learning. You look at the people that are high up, you look at the people that are high up in the likes of Microsoft and it's because they have side projects that they go and work on. You look at who's the Stack Overflow guy that works for Google. I know
what you mean. Yeah,
everyone's their monitor. He's the Mr C#. He's but you look at what he does. He's I see you got drums behind you, Johnny. He bought a set of drums, and the first thing he did was plug it into a MIDI device and write software for playing with the drums. Rather than get the drumsticks out and actually playing with them. It's the first thing he's got a whole kind of blog series about writing MIDI interfaces for his electronic drums, because he wanted to learn how it works. And it's that passion for learning. If you've got that and it's inbuilt, you'll carry on learning, and it means that you'll keep learning, you'll grow in a career, and you'll go on to bigger and better things. I know that the young lady that helps get into IoT, she's got that ultimate passion. You can just see it in her eyes. It's like, when she got the first LED blinking, I got text messages, and it was like, she's awesome, it's so good, look at this. And you can see she's going to go really, really far in whatever field of engineering she wants to go into, because she's got that passion. So just when the kids gone to bed, and just kind of grab an hour and just go and play with tech, whatever it is that floats your boat,
or even start teaching the kids yourself as you're learning. Grab the kids. I mean, I know I've tried, but my kids are so hard work. They're into sport more than tech. I mean, it used to be back in the day when I was a kid, if you're either a sport or you're a tech. But I mean, my kids have. I got to get one of them interested in computing. It's not happened yet, but but yeah.
My youngest, he just turned 12. He's more into sport than tech, but he's mad about space. Yeah. So we've talked about, okay, well, if that's your interest, then we'll talk about things that aren't space related, and about the fact that actually you need tech to get to space. And
Well, I saw you got
It's,
you got your boys to write the program that was run up on the AstroPi, didn't you, recently?
yes,
That was pretty
yeah,
cool.
they got they got their certificate from every year. The Raspberry Pi team and EASA, European Space Agency, get together, and Tim Peake took two Raspberry Pis up to the International Space Station and bolted to the side of the space station. Sadly, they've only got temperature and humidity sensors. That drove me nuts. So,
you can't change the course of the ISS. Then you can't do anything like that with it.
And weirdly, why they put temperature? This is the bit that get me. Temperature and humidity is finely controlled on board the for an obvious reason. Yet the sensor they chose to put on there was temperature and humidity. And it's like, why? And they've, even the IMU device on there, there's no point in having that. We're in 0G.
Yeah.
So, it's like, I was like, why have you done that? It's always going to be the same temperature and humidity because it's fixed. It's a controlled environment. So they wrote a program from Azure Pi. It went up there, and the certificate they get back, they get a certificate signed by the astronaut that helped run the program on the International Space Station. Obviously, electronically signed, he's still up there. And then you flip the certificate over, and it shows the 1 minute time slot that their program got to run, and it's hard cut off as well. So if your program runs more than 60 seconds, tough.
It stops.
Off, the next person gets there. And it shows a map of the world and the trace of where the International Space Station is, and the little segment is highlighted where their program runs. So one of them, their program run over Mexico, and the other one, the program run over China.
Wow.
And they got their 1 minute time slots, and sadly, they don't. And this is the bit I think that got missed out. They don't get the results of their program running. So one of them, they display a bit of text, and then they display what the temperature and humidity was, and the older one put in some eval statements that if it's above this, show wow it's hot in here, open the window, or wow it's cold in here, put a jacket on. And that was his program, fairly simple, basic, but you can see he was going a little bit further with his thinking. I'm not sure they would have opened the window, but he found it funny. But it'd be nice to have seen which bit of the program logic got triggered, so the kids get a bit more feedback.
You would have thought they'd stuck a little camera on it, wouldn't you, and just streamed that camera back down to somewhere, and you can correlate the time and things like that. But I suppose, Cliff, it's just down to that inspiration, isn't it? Like you say, we're back to how do we inspire the next generation, and IoT is certainly a fun area. I mean, but we're over the hour mark now, Cliff, and we can keep going and going. But before we wrap up, you sneakily brought on that Percept kit then quickly. Next month in Microsoft is July IoT, so there's lots of cool IoT projects. I mean, what have you got in? So do you want to take us through that bunch of senders? What are we looking at there, Cliff, and what's it used for?
This here is the DevKit, and it's basically, what it's like with Microsoft. They bring out a new device and says, right, we want to push the industry in this direction, and they bring out a DevKit or a new bit of hardware like a Surface laptop, that sort of thing. And so this is what we think the industry should build, and then all the others come along and build versions of that. This is the DevKit they brought out, and ASUS have brought out a version of this, slightly different, ever so slightly different, but a version of this. You've got the main board here, the NXP board here, which has got Wi-Fi antennas, and that becomes a Wi-Fi hotspot. You can connect it with Ethernet back to your Ethernet and Wi-Fi. You got the camera here, which is just a bog standard Sony camera. It's just magnetically connected to the base, and that's just a normal camera. And you got the and then you got the camera control board under there, which is basically taking the camera feed. You can see there's a port for a second camera there, which isn't enabled in the software at the moment. But that board, you can take this heatsink off, and that board can be used for plugging in cameras and connecting back to NXP, sending data to cloud. Okay. And then you got what they call the Azure Ear, which is you can just about make out the 4 microphones on there, and that allows you to do keyword analysis, wake ups. You can say, computer, turn the lights on, and it will send the signal back to the cloud and back down to your home network to do whatever it is you want to do. Or as I'm looking at with a client, we're looking for it to the camera system to see the fact that, yeah, you are John, and it is you, therefore you're allowed to see this document, but Cliff, I notice you're in the room as well, but you're not allowed to see the document.
Okay.
So doing things like this, and then the Azure ear is going to be listening to the content in the meeting room and transcribing it. Cliff said that, John said that. So you get meeting room analysis and stuff like that. We're looking at a client, and this device for best part of 300 quid is what can do that. This becomes once the first one's connected, becomes a Wi-Fi hotspot, which means it now becomes an edge device. You can connect other devices to it. So it's got GPIO and the like built into it. It's not.
What kind of processing power is in there, Cliff, in terms of the actual compute unit itself? Do you know?
You know what? I don't off the top of my head. I've written a blog post about it, which I'm sure you'll put in the show notes. But it's got an XP chip in there. It's quite powerful. But the board, if you used to look at it, it looks pretty much like a Raspberry Pi kind of style board that's in there. But yeah, it's quite a powerful system, and it connects up to IoT Hub as an edge device. And you can send your data up there, but because it's doing AI at the edge and it runs the AI so I literally trained it with some aircraft components, showed the camera the aircraft components, and trained the model in the cloud. It sends it back down to here, but now it can run the model locally, which means that you're not sending those sensitive images and the sensitive data up to the cloud. It's run locally, processed locally, and then all sent to the cloud is the result. I have seen I've seen Cliff as well. Okay, well, Cliff shouldn't see this, so that's why I'll turn that bit off. So all the sensitive data stays on-prem rather than being sent to the cloud. And yes, the cloud is secure, and it's got a TPM, trusted platform module, which means that its connection to the cloud is completely secure between, from device to cloud, and the connection between each of these modules back to the main controller board is secured as well, using the same technology. So signal from here via the controller all the way up to cloud is all secured. But again, it's secured with what we know today, but tomorrow that someone might find a vulnerability. Hopefully they won't. It's pretty darn impressive the way they do it. But why send the data up? Because it's a lot of data, and image is quite a big file to send up, so you've got latency and stuff. You can process it locally. You remove the latency, you remove the worries that client might have of sending a sensitive image or sound file up to the cloud. So it's all captured and done locally. I was given this a few weeks ago by Microsoft as an MVP to play with. I know Pete Gallagher's got one as well. And we're sort of playing with them, and we're going to be blogging about it. I've written one blog getting started with it, which is on my blog, and I'm sure you'll share the link. And then next month, July, is a whole month of IoT content from the Microsoft IoT team. And it's going to cover things like Percept. It's going to cover things IoT Hub, IoT Central, digital twins, all the different bits of effectively the AZ220 course. It's going to be covered across the course of the month, and all the MVPs and community leads out there are all putting together a blog post which is going to be sent out every day. You'll share the tech community link, I'm sure. But a lot of
we'll put them all in below the video. So I mean, I suppose it's just a case of joining in and getting involved with that that session next month in July. So I noticed you got the likes of Paul DiCarlo, obviously Olivier Bloch, and all those great
and the likes, and Sam George, who heads up the IT team at Microsoft. So it's a lot of but what they're trying to do is, rather than the Microsoft team put this all together, they're trying to get the community to put together what they're working on and what they're doing in the field. So it's going to be a lot of fun projects. I've seen a couple of people what they're putting together already, and it's really interesting. I want to see that. So please,
in fact, I think it was probably July OT last year when I first sort of got that little, burning desire to want to go and learn more. Do you know what I mean? So I think it's it's a month-long event covering lots of different areas of IoT, isn't it? So
me and Pete are heavily pushing for. We've been talking to the IoT team at Microsoft about the fact that we all know what the .NET Conf is. He normally talks about Maui, or he's talking about Blazor and whatever the latest greatest thing is. But we're saying let's have a .NET Conf for IoT.
That'd be cool.
And bringing and showing all the new cool tools off, like all the digital twin stuff that's all being iterated on. But in the last year, so much has come out. And, OT team, it's difficult to keep up. So if you're getting in new, it's easy because you're there, kind of thing. But so much keeps changing. To keep up.
Yeah, I don't think it's any different in any other part of the IT industry at the moment. So
Maui's new. Maui, you don't know, multi-platform app UI is the new version of Xamarin Forms.
Sure. Okay. Yeah.
Xamarin Forms is a way to make a cross-platform, completely cross-platform native app on a mobile device, so iOS, iPad, Android, UWP on Windows. But Maui is the new version, the new iteration that's coming on, and it's basically when Microsoft bought Xamarin 5 years ago. They're now basically bought it in-house, and the Xamarin name's disappearing because Maui is, like it says, using Microsoft.Maui. So it's it's part of the .NET runtime, and it's becoming part of the base class library. So you'll be able to go Microsoft.Maui and then write a program that runs on your iOS, your WinUI, your Android phone, your Mac OS, wherever it is, your TISM fridge. You can write an app for that as well. It's there's a lot of I work in that world as well, but there's a lot of new cool tech that's coming out, and it's exciting.
I think that's all it is, Cliff, isn't it? It's just there's lots of new cool tech, and you just got to get involved. You got to jump in feet first, and you grab the bull by the horns and go and make something. Yes. I think that's the point. It is enjoyable. Well, Pete, I mean we're hitting. Is there anything we've missed off that we want to get in now before we wrap this up? Because it's been. We could make a 3-part special.
The only thing I'm thinking of is go buy your airplane tickets. Come and fly with me, and my colleagues around the world, because we miss having passengers on board. It's boring when you've only got a handful of passengers on board. You don't get to go and say hello and chat to them. And if you're ever on board an aircraft, you are allowed to come and see us pilots. We sit at the front behind a locked door. But if you're on the grounds and the door that you use to board the aircraft, the passenger's boarding door, is open, you're allowed to come and say hi. Obviously, don't walk in. Speak to the cabin crew first, otherwise you will get jumped on. But ask cabin crew if you can come and see us and say hi. We're kept in a dark box and fed crap crew food. It's always nice to say hello to passengers when they come and say hi and see.
I'm gonna have to try and surprise you one day and just turn up on one of your flights. Can I go and say hello to the pilot? Hello.
Come and say hi and see our office, see where we work, where they lock us away for 10, 12 hours at a time.
Yeah, absolutely, Cliff. That's the way, isn't it? But Cliff, this has been brilliant. Thanks so much for spending the time. It's been fantastic, as always. I'm going to catch up with the show on Tuesdays, IoT Live. It's tonight, but not tonight because this goes out on a Friday.
Yes.
But no, thanks, Cliff. That was brilliant. Thanks so much, and we'll speak over Twitter at some point fairly soon, I'm sure, or Twitch.
Yeah, Twitter, Twitch, or wherever, Slack, somewhere.
Yeah, but I'll put all the links, everything we've been talking about. I'll put them all in below. There'll be one master link, and you can go and have a little look for everybody watching for all those things that Cliff has just been talking about. But thank you very much, Cliff.
Thanks for having me on.
Catch up soon.
Bye.